So, good afternoon, good morning, good morning, all. Uh, so, last time when we met on Monday, we have finished the unit number 3, and in your mid exam, up to unit number 3 will come. So, today we'll be starting your unit number 5. 4 I am skipping. Unit number 5, which is transaction processing. Name of the unit is transaction processing. Right. So I would like to know from all, what do you mean by transaction? According to you, what is transaction? Because we'll be learning in very detail what are the transactions, what are the properties of transaction, parallel transactions, what are the difficulties, what are the problems, solutions, all the things that we are going to learn is this particular unit, which is transaction processing. So, but before that, I would like to know from you, what do you mean by a transaction? Any, according to you, anyone here who have not done any transaction in his life or her life? To buy something, okay. Sending money, process of sending money through any medium. Debit from one place, credit to other place, okay. Exchange of entity, anything. Exchange of anything is transaction, okay. किसी भी चीज का लेन देन, sending or receiving, okay. Transfer from one place to another place, okay. So I'll give you some examples. You need to tell me, when do you check your bank balance? You are not sending anything, you are not receiving anything. When do you check your bank balance? Either online or via mobile or by going to ATM. Is it a transaction? No. No. You are checking your bank balance, account balance. Is it a transaction? No. But I say yes. Even DBMS say yes. Because, for example, do you know banks have some limit of transaction ATMs per month? So when you check the balance, it counts as a transaction. Okay, second example. You want to purchase something from Amazon and you have ordered something. Is it a transaction? You have ordered something from Amazon. For example, you want to purchase a mobile and you have ordered the mobile from Amazon. Is it a transaction? Yes or no? Few are saying no. So according to you, only sending money is a transaction, nothing else. So you are purchasing from Amazon, it is a transaction, you are making a transaction. One more example. You are checking price of mobile. You have checking price of the mobile. Still you are not purchasing, but you are checking price of one mobile, then another mobile, then another mobile. Are these transactions? Some are saying no, some are saying yes. Answer is yes. These are also the transaction. Why? when you are checking your balance. When you are checking your balance from your bank account, means you are querying your database. Now you all are knowing select query. You are querying a database to access some value. To access some value. Second thing, when you are checking price of the mobile, so the price may have stored somewhere in the database of Amazon. You are accessing it. Consider you want to fly to your country and you are checking availability of the flights, various flights and the prices of the tickets. Is this transaction? Answer is yes. This is also transaction. So why I am telling you this? Because don't restrict yourself just sending money or taking money or sending something, exchanging something is a transaction. No. Now the definition which is written in your book of transaction. Anything or any activity in which you access the database or updates the database is a transaction. Let me tell you. Repeat. Any activity which either access the database or update the database is the transaction. Now when you are checking your bank balance, it is access or update? Just access. You are just checking the balance. When you are transferring money from one account to another account, access or update? It's update. Because something will be debited, something will be credited. You are purchasing something from Amazon, access or update? Fan, please make this fan on. You can have. So you are purchasing something from the Amazon. Is it access or update? Update, because quantity will be something. For example, 500 mobiles. You are receiving one, so now the remaining will be 499. So you are updating something. You are just checking the price. Access or update? Access. You are booking your ticket. Update, because earlier available seat was something, now -1. Right. So don't restrict yourself as a trans, even non-computerized. When you go to purchase something, you give the money, take something. That are offline transaction. But we are least concerned about offline transaction because we are learning DBMS. So all the activities where you possibly access the database, just access, checking, or update it. Right. I am filling your attendance, access or update? Update. You are checking your attendance, access. Got my? So all these are transaction. Clear in your mind? I just wanted to open your mind about the transaction, because don't restrict yourself. Transaction is just sending money. No. Every activity where you update or access the database is the transaction. Okay? Now we'll start our actual topic. So unit number 5 is transaction processing. So some definition of the book. Now you will understand exactly what I wanted to say. A transaction is a unit of program execution that access and possibly updates the various data items. Transaction is the unit of data item which possibly access or updates the data, or access or update. Transaction is initiated by user program written in higher level language or programming language like SQL, COBOL, C++, Java, any language, doesn't matter. So program can be written in any language. In our laboratories, we are using SQL. It can be any language. Right. The transaction consists of all the operations executed between begin transaction and end transaction. All the activities, we'll see these begin and end in the detail, between begin transaction and end transaction. Now tell me, you want to transfer something from your account to someone else, your friend's account, or account A to B. What are the activities which may be involved? What will be happen in backend database? Exactly. First, it will check the balance, sufficient balance is available. For example, you want to transfer 1000 USD. First, it will check the balance, whether 1000 USD is available in your account or not. If yes, then it will deduct from that account, update the new balance, then it will credit to new destination and update the balance. So many 4 or 5 activities are involved. So between begin transaction always begin with the line begin transaction, like in your C program will begin with has include stdio.h, conio.h. Like every activities, so it is not like that transaction is only of one line. No. Transaction will of multiple lines also. We'll see many transactions in this chapter. So between begin transaction and end transaction, everything is transaction. Okay, everyone? Meaning of transaction? Okay? This question will be definitely there in your exam. Definitely. Explain acid properties of a transaction. Either acid properties, or it will be asked like explain properties of the transaction. So any transaction in your database must follow these acid properties. Now this is not acid of your chemistry. This is not that acid. A means atomicity, C means consistency, I means isolation, D means durability. I'm repeating. A, atomicity, C, consistency, I, isolation, D, durability. So few words are known to you: atomic, atomicity, consistency, or consistent database. What do you mean by atomicity? Chapter number 1. Let's see how you are prepared for your exam. What do you mean by atomicity? So that will see the time of exam. Why are you asking now? We'll read. And we'll go back to our country and we'll forget. Read, learn, forget. Read, learn, forget. Okay. So what I will do, first I will give you the definition of all these, and then we'll take example of our transaction, one simple transaction, and then again we will relearn, because this question is very important. Again we will relearn this, acid properties. Atomicity. Either all operations of the transactions are reflected properly in the database or none are. If there is a debit, then there should be a credit also. If there is a debit, then there should be a credit. What if the money will be debited and it will not be credited? What if you order the mobile? It will be deducted from the database and you will not get the mobile. Either all operation should be reflected, whatever the transactions are, or zero. Either all or zero. This is property of atomicity. Transaction must reflect the property of atomicity. Consistency. Execution of the transaction in isolation, that is, with no transaction executing concurrently, preserves the consistency of the database. We have already seen inconsistent database or inconsistency. What if money is debited and it is not credited in your account? Then your database is inconsistent. So inconsistency should not be there in the database while your transactions are executing. And particularly when parallel transaction, what do you think? When you are purchasing from Amazon, no other can purchase, or someone can purchase. You are the only person who can purchase parallel. When you are checking your attendance, no other person can check. When you are doing the transaction in the bank, no other person can do. Yes, all the transaction will run parallelly. So when there are parallel transactions, there are chances of inconsistency that we'll see. But consistency means the database should not be inconsistent after the transaction. Isolation. Isolation. Now, before reading the definition, isolation, when you are purchasing something from Amazon, can you know some other is also purchasing? No. Like database is also not knowing that the other transactions are running in parallel. Database will also know this is the only transaction which is happening right now. So that is isolation. Every transactions are isolated. So the definition is, even though multiple transactions may execute concurrently, the system guarantees that for every pair of transaction Ti and Tj, there are two transactions, pair of transaction Ti and Tj will notify transaction by T. I means 1, for example, J is 2. Either you can say T1 and T2. It appears that Ti that either Tj finished execution before Ti started or Tj started execution after Ti finished. Thus, each transaction is unaware of other transactions executing concurrently. Database will never know there are other transactions which are running concurrently. They are unaware, but there will be big problems that we'll see. So isolation is every transactions will run as a unique transaction and they are unaware of any other transaction. So atomicity, consistency, isolation, and the last one is durability. So what is durability? After transaction completes successfully, after transaction, the changes it has made to the database persist even if there are system failure. When you take out money from the database or when you take out money from the ATM, even if your ATM crashes, the changes which you have done will be there in your database, which is durability. Atomicity, consistency, isolation, and durability. Now, same property we'll explain by one example, so you will understand how are these properties work. So to learn this example, you need to know two operations, read and write. Read and write. Now to know the read and write, you should know the difference between primary memory and secondary memory. Do you know what is primary memory and secondary memory? What is primary memory? RAM. Primary memory is RAM. What is secondary memory? Hard disk. What is the use of primary memory and what is the use of secondary memory?
When we want a data to last long or store it for a long time, then we store it in second memory.
Okay. So this PowerPoint presentation, where it is stored? In primary or secondary? Where it is stored? When it is closed, not open, it is closed. When it is stored? In hard disk or secondary memory. But when I open it, it will be brought from secondary memory to primary memory. That means all the active programs that are in the primary. But when I do the changes and if I close and I save, what will be happen? It will be brought out from the primary memory or RAM and it will be stored in the secondary memory. Everyone is knowing this difference? Primary memory, secondary memory. Same way, your database is stored in secondary memory, hard disk, in the disk. But when you want to access the database should be brought in from hard disk to RAM. Same way, when you want to update your account, transferring money, first what? That account number or account, that entity should be brought from secondary memory to primary memory, do the changes, and again store it into the secondary memory. So for that, there are two operations, read X and write X. X is any data item. It is a database, it is a account number, it is a mobile quantity, value, price, whatever. X is the data item. So read X means which transfer the data item X from database to local buffer. Database which is stored in the secondary memory belongs to the transaction that executed read operation. So when you are doing any transaction, the database is allocate a small space to your transaction in the memory, in the RAM. So when you perform read X, read means it accesses the value from the database and stored it inside the buffer which is there in the primary. And what is write? It's reverse. Write transfer the data item X from local buffer to the transaction that executed right back to the database. So read, everything in the transaction is depending upon read and write. That's it. You need to understand what is read, what is write. I want you to understand what is read and what is write. Read means transferring the data item from database to the buffer. And write means from buffer to the database. If you want to access any data item, that must be inside the buffer. Otherwise, you directly cannot access or update any data item. Got everyone? Everyone back. Got it? Your neighbor. Sleeping? Right? Should I show you one transaction so you can? This is one simple transaction. Can anyone tell me what is this transaction doing? No, generally I'm asking in single line what it is doing. Okay, excellent. It is transacting 50 from A to B. Now it can be account money, it can be quantity, it can be anything. But transacting 50 from A to B. So first read A. I told you first debit, first credit will happen or debit? First credit will happen or debit? Debit, obviously debit, right? So what it will do, it will first read A. It will check whether the 50 is the balance. Then it will do the transaction A is equal to A minus 50. Then write A, whatever the updated balance after deducting, it will write back to the database. Then read B. Now credit will happen. So it will read B. B is equal to B plus 50. It will credit 50 and again write the updated balance to the B. Got the point? Right? You can? After read, you are deducting $50, okay? I perform any operation after write.
Generally, do operation after the right operation.
After write, yeah, you can do any. This is just example. We will see many such examples where different operations we will do. This is just a simple example, but you can perform any operation. Not you, but your database. You wait and watch what will happen. Now we will see acid properties with help of this example. First, atomicity. Can anyone explain what is atomicity with respect to this example? Okay. So consider you are executing this transaction, system will fail over here. Failure. Database fail, hardware fail, server crash, whatever. So what happened? Money was debited, but it was not credited. Will you accept? This person will not accept. So atomicity means either transaction should complete till this or till this. Not here. Partial transaction executions not allowed. Right, which is atomicity. Consistency, inconsistency means, let me tell you the balance. Balance of A is 1000, balance of B is 1000. Both the balance before transaction is 1000. Now tell me after transaction what are the balance? A 950 and B is 1050. What is the total of A plus B before transaction? After transaction, 2000. Now consider here the database gets failed. What is the total after transaction? The transaction finished here. What is the total? 1950 because this is debited, so 1000 becomes 950. But it is still not credited, so it is 1000 only. So 1000 plus 950, 1950. This is inconsistent database. Total before transaction, after transaction should be same. So if Amazon is having 5000 mobile, you purchase 10, so Amazon balance must be 4950. Sorry, 4990. So before transaction, after transaction, total should be same, which is database consistency. Then isolation. Consider one more transaction executing here. One more transaction. Just imagine. Which do the total of A plus B. Which do the total of A plus B. Now this transaction will start after this. It is not like that the transaction, the entire transaction will get executed. It will be stopped. The new transaction will start A plus B. So A balance, what it will be? A's balance 950. B's balance 1000. Our earlier example. So total will be 1950, which is wrong. Which is wrong. Why? Because there is a parallel transaction running and this transaction is not running. This is the property of isolation. Durability. Consider the system failure done over here. So if there is a system failure after write operation, then it should not affect the new value. If there is a system failure here, then you should have the provision that the S balance should be again 1000, not 950. If the system balance is here, then S balance should be 1000, not 950. If system failure is here, then S balance would be 950, this balance would be 1050. So that your durability property should be maintained. If you can't, in your country, it's a parallel. Yes, your question is right, but your answer I will give not today, but after we finish this, because our next topic is concurrency control. How the database ensured parallel in your Amazon, right? Same Amazon. When there is a sale, millions and millions people are buying parallelly. One product. Then how database will ensure? There are lots of protocols, lots of technique, but your question is very right. But we'll give answer after we learn concurrency control protocol. Right? Yes. Atomicity. Atomicity is in either the transaction should complete entirely or zero. If transaction will incomplete after write, then all the changes a transaction has done must be undone. Must be undo. How undo with that also we'll see. So same, see, consistency requirement here is that sum of A and B be unchanged by the execution of transaction. We'll see. A plus B before transaction 2000, after transaction also 2000. Without the consistency required, money could be created or destroyed by the transaction. If 1950 is there, then 50 money, $50 destroyed from the system. The bank will not be happy and account holder A will not be happy. Atomicity. If the atomicity property is present, all the actions of the transaction are reflected in the database or none are. If write A is reflected, then must be write B. Either all or none. No partial transaction should be allowed. Durability. It must be the case that no system failure will result in loss of data corresponding to the transfer of fund. Bank cannot tell you, sorry, our server was crashed, so we lost your balance, now your account is zero balance. No. right? We can guarantee durability by ensuring that the update carried out by transaction have been returned to disk before transaction complete. So before the transaction complete, all the changes that transaction has done should be returned to the hard disk. Number two, information about updates carried out by transaction and returned to the disk are sufficient to enable the database to reconstruct the update when database system restarted after failure. It is telling about log. What are the updates that you are doing? It must be recorded somewhere. We'll see log-based protocols also. There is one topic here, log. Do you know log, LOG, log? Right. Whatever the update that you are doing, it must be written somewhere that I have deducted 50 from A, I have credited 50 from B. All the series should be recorded. For example, in the laboratory, if you want to go to library, you are punching, right? When you go to library, you are not punching. You are not typing your enrollment number. Library. For taking book, you are going to live, not up, down. It is logging. It is logging because whenever we want to see how many users have visited the library, we can see. This is log. And the last one is isolation. Last one is isolation. So isolation property is if several transactions are executed concurrently, their operation may interleave in some undesirable way, resulting in some inconsistent state. I have taken example of A plus B. If the second concurrent running transaction reads A plus B at this intermediate point, then it computes A plus B, it will observe inconsistent value. So it will read A plus B is 1950, which is wrong. Which is wrong. Got it? So last topic we'll see transaction state. This is last for today. So transaction state. The transaction can be in this state at any time. So active, and consider the arrows also. So from active, either it can be partially committed or it can be failed. From failed, it can be aborted, partially committed, committed. So transaction can be in the 5 state. This is a 5-state diagram. In few books there are 3 state, few books there are 7 state, few books there are 9 state. But we don't consider these all. These are the main 5 state. Let's see one by one. Active. Active, the initial state. The transaction stays in this state while it is executing. While the transaction is actually executing, it is in active state. When transaction is actually executing, then it is in active state. Partially committed. After the final statement has been executed. See, it is not committed. That means it is not completed. When the transaction will execute its final statement, then it is partially committed. Fail. After the discovery that normal execution can no longer proceed, transaction can be failed. So, from active, transaction is right now executing. If transaction successfully execute the last statement, then it is partially committed. Or in between, due to some failure, transaction can be failed. But after partially committed also, once the transaction is executed, the last statement, if something happened before the changes has reflected to the database, then it is also called. Once the transaction, whatever the changes transaction have done, it is reflected in the database and it is committed. Committed means all the changes the transaction have done is reflected in the database or aborted. Transaction abandoned, or you can say cancel. After the transaction has been rolled back and the database has been restored to the previous state, start of the transaction. All the changes, if transaction is aborted, all the intermediate changes which it has done, it is restored to the starting point. Committed after successfully completion of the transaction. So in your exam, it may be asked only to draw the diagram. Draw 5-state diagram of transaction state. But you need to take care of error. See, when it is failed, then it cannot be start again. When it is failed, it cannot be active again. When it is partially committed, it can be failed or it can be aborted. If it is committed, then over, all the changes has been done. Aborted means all the changes will be undone. So these are the transaction stage. Okay? So we'll keep up to this. Tomorrow we'll jump to your question, that is concurrence and execution. These are the topics. Okay, that's it from today. Thank you. Chats. Okay, students who are online, thank you.